everyone. Welcome to the AWS Cloud Performance Summit. Today's event was organized by the hardworking folks at AWS Insider and Virtualization Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsors, enterprise-grade open-source solutions provider SUSE and cloud data management and protection provider Zerto for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief in the Converge 360 group of 1105 Media, and I'll be your sponsor for the first of 3 information-packed sessions. But before we get started, I need to go over just a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It will be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsors, SUSE and Zerto, have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And at the end of the summit, you'll be asked to take a very short survey. Please take a moment to share your opinions. Our editors actually read every comment. I'm one of them, so I know it's true. Your opinions help to shape our future events. And last but not least, at the end of the third session, one lucky attendee will be receiving a DJI Mavic Air 2 drone, the next big thing in aerial content creation that combines high-end imaging features and powerful flight performance in a compact form factor. But you must be present to win, so stick with us. Now let's get started with our first session, what's new and what's hot in AWS Cloud. For this session, we've called on cloud security architect Stephen Smiley. Mr. Smiley is a consulting director at ScaleSec, where he leads cloud security advisory and engineering efforts. A former military intelligence officer, he balances strategic and tactical thinking to help his company's customers accomplish their objectives. I know you're in for a great session. Take it away, Stephen.
Hey, John. Thanks for having me today. Really happy to be here and to talk about some of my kind of favorite topics, right? Like what's new and what is everybody talking about? So that's what we're all here in technology for, right? I am an AWS ambassador. I've got a handful of AWS certifications, and I just do this all the time, and I really, really love it. We're going to save plenty of time for the Q&A section at the end here. I'd love to hear from you on, what's on your mind in cloud and, what are you building? What are you thinking about? What challenges are you having? And I'll even throw out there that I will be at AWS Reinforce in Boston in about 2 weeks. And if you happen to be also attending, send me a message on, LinkedIn or Twitter or something. And let's get together and talk about what challenges you're having in the cloud. I just love hearing from people and what they're doing. Some of the topics that I do on a regular basis and that I do at ScaleSec are things like build, tailored landing zones, a new AWS environment to bring in your existing workloads or set up a secure foundation for your for the things that you're thinking about building. We also like to set up secure engineering foundations, right? Get you started on the right foot with infrastructure as code and continuous integration and deployment. Something that I really enjoy is assessing security of environments. So if you've got questions around that, let me know. I really like assessing security of existing environments, to helping you develop security and compliance programs, things like that. So let's talk about what's new and what's hot in AWS. But please feel free to send in any questions. I'd love to talk about it. So I've picked 10 things that I think are the most standout things for what's new and what's hot. I've got them up on the agenda today. We'll talk about each one for a couple of minutes. And the trick is, of course, that there's even more things since I put this list together. So just within the last week, AWS announced Redshift Serverless, their data analytics service. Their data warehouse service is now serverless. So that didn't even make it to this agenda. So maybe we'll make it to the next one. But we are going to talk a little bit about serverless capabilities right off the bat here. So Aurora Serverless version 2 was released as generally available. And that's the pretty big news. Aurora Serverless has been around in a preview mode for about a year now or so, and now it's considered generally available. So Aurora is their relational database service where Aurora can, it's compatible with Postgres and MySQL, but they've made a lot of performance improvements, and it has, better cost characteristics. But now with their move towards Aurora Serverless, what they're really trying to do is make it even lower cost and lower management. So let's see what did we get with Aurora Serverless. The main thing that you do get is instant scaling, and I've got a graph here on the next slide. But I want to point out that scaling can grow capacity very quickly. It'll add CPU and memory to the underlying instance without you really needing to do anything. And then it scales down more conservatively in steps, so that if you do experience spikes, that it's not constantly moving back and forth. But an important thing here is that it does not scale down to zero. And so in some people's minds, serverless has come to mean that it's going to scale down to zero and it's going to be purely event-driven. This did not meet that definition, but that does not necessarily mean that it's a bad choice for your workload. And we can talk a little bit more about that here in just a second. But one thing that's pretty cool is that you can mix Aurora Serverless in with non-serverless in the same cluster, right? So many of us are used to building Aurora clusters where we've got a write instance, and then we've also got some read replicas where those replicas are just used for reads to take the load off of that main write database, especially if our workload is very read heavy. And so having a serverless read replica gives you the ability to scale up instantly and capture, some big spike in traffic, without going down. But you can still run your main write database exactly as you like it. So that's one approach that people may consider taking. And it brings up this question of what is serverless, right? I would say that a lot of people are disappointed with Aurora Serverless version 2, primarily because it does not provide a data API. It needs to be placed in a VPC network. So DynamoDB, for example, is AWS's NoSQL database that many consider to be a kind of ideal or very pure serverless database, in that you don't place it in a VPC really at all, right? It's just accessed through API calls. You call it when you need to make a write. You call it when you need to make a read or a query. And you never have to think about its network traffic whatsoever. You never have to think about securing it on a network level. Nothing can reach it on the network. Its only surface area is the data API. And Aurora Serverless version 2 does not operate like that. You're still going to put it in a VPC. You still have to think about its network configurations. So it's less serverless than something like DynamoDB, but you still have much less management of it, especially when it comes to scaling. But I just want to point out that since it's not scaling to zero, even if you just have it at like a 0.5, capacity unit, the minimum that you're going to spend on an Aurora Serverless instance is $45 a month, which is unfortunately probably too much for every developer having a development environment with one in it, which is something that many people do with some DynamoDB, because that costs pennies if you don't have a bunch of activity on it. But here's the graph on the screen showing its scaling characteristics, and this is impressive. So we can see that we get orders in this blue line that pop up right at 1543 on the screen, and the database capacity is is quickly increasing. It jumps up at like 47 or so, and it's starting to increase capacity to meet that increased demand. And by 1555, we've got a big peak of orders, in excess of 10,000 orders, and the serverless capacity has gone up to 14 capacity units, meeting that demand. And then, the flash sale orders drop down very quickly, and the serverless Aurora's capacity then kind of steps down conservatively to make sure that if there is a second spike, it's available. So the main lesson here is that all those orders were captured, right? I was not necessarily expecting that, or maybe I was doing a flash sale, but either way, I didn't have to do any management whatsoever to this database to scale up from something like 1,000 orders to, over 10,000 orders. And that's the beauty of serverless, right? Of course, you pay a little bit for that benefit, but that's the beauty of serverless. And so on that topic, I want to talk a little bit about the serverless spectrum, because this is a hot topic in AWS. AWS is constantly saying that new services are serverless, right? We talked about Redshift serverless earlier, and they've even got like Elastic MapReduce serverless. And so they've been pushing this, and a lot of people are saying, well, those aren't really serverless. I still have to, configure the underlying storage, or I still have to, put this in a VPC. That's not serverless. And so the debate, in my opinion, is converging towards goals of serverless being low operational burden, letting your workloads be fast to build, and really letting development focus on the business value of the workload, and so much less about configuring the infrastructure. So with those goals in mind, we can see serverless being on a spectrum here, with some things being more pure, like S3, DynamoDB, and Lambda, but that doesn't mean that everything's going to be on that same level. Other things like Aurora Serverless or Fargate, which require some setup, may still be considered towards the serverless end of the spectrum, especially when compared to pure EC2. So anyways, this is just a great way to think about what serverless is, and when you're building your architectures and you're picking some solution, you want to find the balance for your workload and your trade-offs somewhere along this spectrum. Along that topic, one of the other new releases is a workflows collection for AWS Step Functions. Now, Step Functions is one of my personal favorite services right now. It's something that I think is going to continue to grow, continue to improve in utility, but is already extremely useful. If you're not very familiar with Step Functions, the idea is that you can actually visually connect various actions together in a workflow. And you could have branching operations where it handles errors or retries, and those steps can even wait. And while you're waiting, you're not paying for some compute service to wait around idle, but instead you're only paying for the invocation of your workflow and the step transitions. And so Step Functions, especially with the ability to call any AWS API, has become a major favorite among serverless people lately. And to help highlight its utility, this workflows collection is starting to drop a number of patterns that you may want to leverage in your application. So right now, there's not very many up, but anybody can submit new ones for review on GitHub, and they will get incorporated into this website at serverlessland.com. So I encourage you to go check this out and learn about the patterns that people are building, and consider where you might incorporate some serverless logic into your application. Another big new release, very recent, is IAM roles anywhere. Now, this is a big deal because it's a major change to authentication with the AWS service. So for a long time, security advocates like me have been saying that IAM roles are the way to go. They are temporary, and their credentials will expire, and they don't have any risk of persistent keys being left out there. They do have, some access keys, but if you were to commit them to a source control repository, they would expire within a few hours. So there's some risk there, but it's certainly not the risk of having permanent credentials out there. And, other things that maybe less negligent, but just like if they're stored on your local laptop and somebody gets your laptop, well, if it's been 8 hours since you logged on, now your role has expired, or whatever your session duration is configured to. It's just so much better to have temporary credentials than permanent ones wherever you go. The problem was there's a lot of other applications that needed to reach things on a regular basis, and we couldn't issue them IAM roles. So that's where this comes in. So if you've got workloads outside of AWS, maybe they're on-prem servers that are calling AWS APIs. IAM roles anywhere allows you to use X509 certificate to retrieve temporary credentials. So it'll authenticate, get that credential, and then it can be used like any other IAM role. It takes a little bit of setup where you have to register a trust anchor with certificate authority and then create the roles that will trust IAM roles anywhere, so in your AWS account. And then you'll create some profiles to map those roles to the workloads. I hope I'm not making it sound too complicated, but the point here is that at the end of the day, you'll have a external workload set up to do this credential process, and they provide that script, and it's actually automatically used by all the AWS SDKs. So if you've got this external workload, it can authenticate, and you don't have to give it any maintenance, and it doesn't have permanent credentials, so you can revoke those as needed. I would say that I'm not jumping to use this right away because I don't have any workloads that require this yet. But I'm interested to see where this goes because anytime I've got an external party, like let's say I've got a third-party monitoring tool that's going to reach into my AWS account to pull some data, I don't want to give that an IAM user. That's something that people have been doing for a long time. Instead, I want to create a trust based on certificates between those accounts, and then all the authentication will just be temporary. So we'll see how that progresses, but this is something to definitely watch. All right, the next topic, the next new release is WAF CAPTCHA is now generally available. So the web application firewall, AWS WAF, has been around for a while now, and it's been quickly building up new features. We've got bot control capabilities recently, and it's already got a number of built-in rules for filtering out, common SQL injection attacks or cross-site scripting or, common security concerns. But one of the capabilities that just was missing for so long was the ability to kind of redirect to a CAPTCHA, right? So if I don't know if something's a bot or if it would be blocking too many legitimate requests to just say, all right, block under these conditions. Instead, you can redirect it to a CAPTCHA that we're all pretty familiar with. And I've got some examples on the screen here, but it's got like a little image puzzle. It supports audio for accessibility. And so this could be useful for a lot of applications. And it will use tokens to track successful responses to CAPTCHA challenges, so your users aren't getting hit with this CAPTCHA all the time. And you can configure the immunity time. So the default's like 300 seconds, but you can change it from anywhere from 60 seconds to 3 days. And as long as the user still has a valid token from a prior challenge, then it will, still let them through. So that's awesome. One of the ways that I see myself using this is setting rate-based rules that will block traffic. I can keep the rate limit relatively high to avoid blocking legitimate users, and then add a second rate-based rule that's below that blocking rule that will just send it to CAPTCHA. So if there's a legitimate user who's maybe coming at me really fast, they'll hit the CAPTCHA. But if there's a bot out there that maybe they've broken the CAPTCHA and they've got a way to hack this, they're still going to get hit by that higher limit rule. So I've got a little bit of defense in depth there. Because one of the things that we have to accept is that a lot of CAPTCHA challenges have basically been solved by machine learning and artificial intelligence techniques. And so we have to be prepared for that. Okay. The next new release we've got is AWS Config now supports custom rules in a special domain-specific language called Guard. Now, this is very exciting. So AWS Config is the asset inventory and configuration management service within AWS. And one of the key things that it can do is check your configurations for specific policies, right? A kind of classic example is I don't want any security groups with SSH open to the world, right? That's like a pretty obvious one. It's like I really just don't want anybody to be able to SSH into my environment, even if I accidentally have that open. And so config comes with some managed rules that are built by AWS. But as we all know, those managed rules can be helpful, but I need things that are customized to my environment and my context. Now, in the past, you would write a Lambda function for your custom rules, which that works, but it's not great, and it requires some maintenance, right? And it's kind of annoying that I have to make a Lambda function for that. So instead, Guard is this kind of declarative language that gives me a chance to say, this is my policy, and apply it in a much more like readable, simple way that you're probably going to be a lot more maintainable as well. But the really exciting thing here is that Guard applies beyond config. You can also use Guard with CloudFormation or Terraform templates. So with your infrastructure as code definition, you can apply the same policy during your CI pipeline to prevent creation of those resources, those non-compliant resources, in the first place, right? So I as a developer can run this as part of my process on my local machine, right? So I can have like a pre-commit configuration that runs Guard, runs Guard against the template that I'm authoring. And if it violates the policy, I get to know right away. But then I can also run Guard in my team's continuous integration to make sure that nothing gets merged to my master or my main branch that violates these policies. And then the deployment goes in, and config is checking that in the running environment, nothing is violating that same policy. Now that's pretty cool because that's 3 different places that I'm applying to both prevent and detect, and I only had to maintain that custom policy in one place, that's very powerful. So this is similar to HashiCorp's Sentinel capability, which they have as part of their cloud offering, and you have to pay a pretty significant amount of money for that, and that is only going to apply during the deployment process or during the integration process, but it doesn't apply once everything's been deployed. So if someone gets in and makes a change to my environment, Sentinel can't find that, but config custom rules can. So this is pretty exciting, and if you've got special security requirements, I would keep an eye on this and consider integrating this across your environment. Okay, the next topic here is something that I consider to be very hot in AWS. It's not brand new. I think this was released about 6 months ago, but still, as I have conversations with people using AWS, they haven't gotten this message, so I want to make this message loud and clear for everybody. S3 Glacier has been overhauled. So now there is S3 Glacier Instant Retrieval. So they've done a bunch of renaming in this. And Glacier's gone through a whole journey, right? So Glacier actually used to be separate from S3. It was its own service. But that, of course, didn't really make sense because S3 was supposed to be their main object store. And so they integrated Glacier into S3, at least from the user perspective, as a storage class. The problem was, man, Glacier was painful if you needed to retrieve that data. It was easy to send it away. It was easy to create a lifecycle policy and push all my data to Glacier. But then when I need to bring it back, which might be rare, but when I do, I need it. Like, I need it now. I don't need it in 3 months, right? Like, I have a specific requirement. I need to look through those old security logs. I need to now. Man, Glacier was really annoying to pull it back. If you didn't consider packaging up your data into zip files with clear names, you'd have to make a script to try to go pull them, and you have to pull too much, and it's going to have a whole delay. And it was headaches for anybody who had to deal with this. So anyways, so S3 Glacier Instant Retrieval now has much faster retrieval. It's still something that you will pay more for if you're accessing it frequently, right? You still only want to use it if you're accessing that data like once a quarter, but at least you'll be able to pull it back right away. And it has the same latency and high throughput performance as S3 standard, so that is awesome. But you're going to get like up to 68% savings, even compared to infrequent access. So infrequent access used to be my go-to. If somebody said, I want to archive this, I don't think I'm going to use it, I would tell them, yeah, just put it in infrequent access because you really don't want to deal with the headaches of Glacier. But now with instant retrieval, Glacier is a viable option again in my mind. So the main things to take away from this is when you're considering your storage classes, use Glacier Instant Retrieval if you're going to access that data, less than once a quarter. Standard infrequent if you're going to access it like once a month, and standard if you're going to increase it more than once a month. And if you really just don't know, then use intelligent tiering. It will use the above storage classes based on your storage patterns. It unfortunately has some different names for them. Like, it'll call them archive, infrequent, and frequent rather than instant retrieval, standard, infrequent, and standard. So it's a little bit annoying to keep the names clear. But at the end of the day, intelligent tiering will get you into the right storage class without you having to, configure it deliberately. Okay, the next one is IP Address Manager, and this is also pretty hot. It's not brand new, but not enough people are using it. One of the things that I do a fair amount is help companies build, AWS landing zones and try to, set up a comprehensive security and management system for their environments. And some environments are small, and so they might not need too much setup. But if you have any network that's larger than a couple accounts, you're going to start thinking about your IP address space, and you don't want to change that later when you suddenly have, 12, networks that all need to consider each other, right? So IP Address Manager helps you manage, monitor, and audit your IP address allocation at a significant scale. So you'll create a pool of IP addresses, and you set up a pool hierarchy. So I've got some screenshots here where on the left you're seeing that we're creating the pool and the address family in like a CIDR block like 10.0.0.0/14. So I get this like big block, and like that is what I'm going to divide. And then I can set it up in a hierarchy, and in this case we've got it aligned to different AWS regions. So I've got a pool for US East 1 and a different one for US East 2. And so on. And then you when you go to create a new VPC, rather than specifying exactly what CIDR block you want, you specify a pool that you are going to draw from. And so that actually makes it a lot better in automation. So if you're doing automation that might create a VPC, it could just all point to the same pool. It doesn't have to have a variable for, or any sort of parameter for the CIDR block. And so now you're pulling from that pool, and that pool keeps track. And then you get this monitoring screen that I have on the right image here, where you can see all the different VPCs in that pool. What is its CIDR block, and how many IPs are being used in it? Are the addresses overlapping or not? And if they are overlapping, you can see it, and you can go resolve that. So if I am running a network team and I need to make sure that I've got non-overlapping pools, I can do that right here with central management and visibility. And I don't have to go and manually look at all of them. Those of us who didn't have this, we used to write scripts to go and pull all of our AWS accounts and all of the regions to find that out and try to reconcile. And man, there was just no great way to do that. And so here we go, IP Address Manager solves that problem. The next hot thing to talk about here is CloudTrail Lake. This is still relatively new, and CloudTrail Lake gives you the ability to query your CloudTrail logs much better than you used to be able to. So CloudTrail records all of our API actions in our AWS account. So every time someone logs in, I have an event. But beyond that, I've got every time that somebody, pulls data out of S3 or, creates a new bucket or changes a security group or, any of the actions that we're doing in AWS, that's recorded in CloudTrail. It does not record actions like, within my VMs. This doesn't replace system event logs or application logs, but this is just focused on what's going on in your AWS cloud environment. The problem was that CloudTrail did a great job recording it, pushed it into an S3 bucket, but there wasn't a great way to query those logs. And if you were never looking at them, then okay, that's not a problem. That's not necessarily, but now there's an incident, right? Or I want to know who created this, who made those changes. When's the last time that Josh logged into our environment? Josh logged in? I thought he left 3 months ago, something like that, right? If you don't have a great way to query those, you're going to be in trouble when you actually need to investigate something. And it's not necessarily a security problem. It could also just be general operations and knowing what's going on. So one way to do that has been to push your CloudTrail logs into CloudWatch logs and then query them there. It's just not the best option. The CloudTrail logs can get big, and CloudWatch logs will end up charging you a bunch of money for that. And also, CloudWatch logs doesn't have the most robust query language. So what many of us were doing for a long time is we were using Athena, the service that can perform SQL queries against AWS S3, to look through our CloudTrail logs. And basically, CloudTrail Lake is that, but productized with a much better front end and a much better interface. So you can set your CloudTrail Lake retention period from anywhere from like 7 days to 7 years, which many of us are going to want to do for a long time for compliance reasons, or just because we really want to make sure that we know what went on in our environment. You can configure it to include just management events and or data events if you need to. And then you can use standard SQL queries to look through those. So an example on the screen here, we're saying I want to see the event time and the user identity in the region from a specific event data store, where, the event time is before this time and after this time. So I'm looking at a specific time period. I want to know, actions from the AWS region in US East 1 and US West 2. And I want to know, and I want to see all the, event console login. So I'm going to set, so in short, I'm just saying, hey, tell me all the times that someone logged in to this region during this time. And I'm going to get a list of results, and I can see all the users that logged in. That is very helpful if I'm trying to get a sense of what's going on in my environment. Cloudtrail Lake comes with some sample queries that might be helpful, and you could even save queries that you intend to run on a regular basis. So if you don't currently have a way of querying your Cloudtrail logs, this is a great, simple, straightforward way. And because it's just using SQL queries, then you don't have to learn a special language for that. That's pretty common. One of the reasons that you might not use this is that you've got some other more robust SIM type product, right? Like a security incident and like event management. If you were sending your stuff to Splunk Cloud or Sumo Logic or Google Chronicle or whatever product you may have, it's probably preferred to put all your Cloudtrail logs along with your other things so that you can correlate them with other events, so that you can see them alongside application logs or maybe network flow logs or whatever else you've got. So if you've got a better tool, then this is probably not the one for you. But if you don't, and you don't really need all of that, this will save you a lot of time and money by just enabling this right here in your AWS account. Okay, so the next one is Fleet Manager. So this gives you the ability, this new release gives you the ability to remote desktop into Windows environments. So you don't even need public access. It just uses its agent, so you're not even opening 3389 to anybody. So as long as you've got System Manager enabled, which of course you should, so that you can configure patch management and asset inventory and so forth, then you can get a remote desktop right to that, right there in your browser, and that's very convenient. You can use the username and password, but you can also use the EC2 key pair, and that is very convenient. I have been using this a lot for those people that still require Windows Server out there, and we still need to access it, but I don't want to open up all of my remote administration ports across the board. And then the last one here is Data Sync. Data Sync now is the ability to move data between clouds, and this is becoming more and more frequent as more and more companies are multi-cloud. So one of the patterns I'm seeing a lot is people are in AWS S3. They want to do some data analysis, but they would like to use Google's BigQuery instead of Redshift. For whatever reason, BigQuery is pretty great. Redshift isn't that bad, but their data analytics team works over there. So Data Sync can do this for you across clouds. It runs an agent on an EC2 instance or any kind of compute instance. And within AWS, you can just launch that from an AMI that's got the agent already installed on it. And then you just kind of configure the source and the destination. You can exclude files or, set a bunch of configurations. But it'll allow you to move something from S3 to, Google storage or, any other way. One of the things that's pretty cool is that you can also run the same agent in a different cloud. So you could run it on a Google Compute instance, for example, to pull data from Google storage over to S3 and then work on it in AWS. In general, you want to run this agent in the source location because it's going to do some compression and you want to minimize the data egress costs. But Data Sync is going to handle end-to-end security, doing encryption and integrity validation of that transfer. So you can ensure that you're moving that securely. And again, I'm just seeing this a lot lately. We know in cloud we want to minimize how much we're moving cloud or moving data across because That's one of the most expensive things out there, but it can still definitely be worth it if another cloud has the service that you need. So DataSync can do that for you now, and that is awesome. Okay, so we covered a lot of different topics today. I'm open for any questions that you've got. I can take a look at the Q&A box, but yeah, let me know what's on your mind.
Sure. Thanks, Stephen. I want to remind everybody you can still type your questions into the Q&A box at any time, and we'll do our best to get to all of them. Let's start with this one from Eric. What are the best tools for monitoring serverless performance?
That's a good question. So there are some tools within AWS that I do recommend using. So AWS X-Ray is going to be great at understanding the different paths that your serverless applications are taking, and narrowing down into which parts of my requests are taking longer and so forth. But I want to point out that there are a lot of third-party tools that are getting some really good attention. So I can't endorse any specific thing, but a lot of people are really enjoying using Datadog to do monitoring for their metrics. And let's see, what's the other one? The other one is Lumigo, Lumigo. That is one of the that tool is being used and getting a lot of praise in the serverless community right now for visualizing serverless environments, getting alerted to issues, and just giving you kind of a more single pane of glass type view of Lambda performance. And so I would recommend checking those out. Every day AWS keeps pushing serverless stuff and improving all the services around there. So keep an eye on that, but don't be afraid to go third party if you have a good use case for that.
Awesome. Okay, here's one by I'll get pardon my pronunciation, Jay Prasad. Is there a list of all services available from AWS as of today, like a cheat sheet to get more info at a glance? Please let me know if possible.
Sure. So, so to get an overview of all AWS services, there's a few different ways you can go about this. Because you're right, there's a lot, right? So you can make an AWS account and you can log into the console and click on services, and it's going to fill up your screen and more, right? You'll have to scroll down. And it's got a bunch of categories. And so that is one way to explore them that will work, right? And you click on a service that you're not yet using, you'll get a little bit of a blurb. I think that's okay. But you can just also go to the AWS website and kind of look at it by their different categories, which is probably a little bit more helpful by thinking about, all right, well, what am I doing? And you can also look at like AWS solution implementation things where they have those categorized by some different industries, and they've got some example architectures that might help you understand the services available. But to answer your question more directly of can I get a list of all of them? My recommendation would be to go to the AWS documentation website, and you can get a full list of all the documentation pages that they have. And every doc page starts with an overview of what is this and what are its core concepts and why would you use this? So that would be, if I personally, that's where I'm going to go if I want a full list of everything. But I will recommend for you to also go and look at the frequently asked questions page for the services that you think you're going to use before you start building anything. Because the frequently asked questions are very good at explaining some of the nuances. Almost every single one will have a question that's like, why would I use this over this, right? So for example, why would I use simple queue service over simple notification service, because they're both kind of messaging services, right? And the nuances and differences there will be obvious to those who have used them, but really not obvious if you're just reading the overviews. So hopefully the FAQ clears that up. Yeah, that's the way that I would go.
Okay, here's one from Thomas. He wants to know, the logging is such a need. Can you discuss how these tools interplay with audit and compliance functions?
Yes. So logging, of course, is going to come from many different sources, right? And when it comes to compliance and your audit, you're going to want to have a clear kind of matrix of all the different logging sources that you have, right? And what layers they exist at, what service is providing that logging, and then where they're stored. And so my first recommendation is to build out that whole kind of matrix, that table, and then make a plan for how am I going to make sure that those are automated across the board, and where are they stored. And when the auditor shows up, I want to be able to give him very simple instructions of here, go look here, right? And not have to give him, a bunch of different things to track down, or now I have to solve it. So anyways, almost all of these tools are going to give you the ability to export your logs to AWS S3, and so that's probably the simplest and cheapest way to do it. But for key compliance functions, right? So, for example, your security posture monitoring, right? Your configuration posture. With AWS Security Hub is the main tool for that, and you've got CloudTrail for your management events, config for your asset inventory, GuardDuty for threat detection. Basically, all of those can be logged by AWS Audit Manager. It will ingest the logs from all of those and store them in a separate place where it's not going to be tampered with. And again, it's not turning on those logs for you, but it will tell the auditor that you had all of these on, and it keeps track of them. And so that's what the auditor is going to look for, and that is the lowest effort. I'm not going to say that Audit Manager is amazing, because I still feel like it's kind of a raw service. The logs you're going to get out of it are very, very boring, but that's the kind of stuff that auditors love, right? And it'll have all of them. So that's probably the easiest way to make sure you've got it all stored. I'm hoping that answers your question.
Thank you. So Thomas is wondering, when you set up CloudTrail Lake, is it able to look into the history, or only from when you turn it on?
That's a good question. It's really only when you turn it on. And that's why I recommend anytime you start a new AWS environment, get CloudTrail set up right away, because you just don't want to forget. And that's something that I do when I'm building new AWS environments. Yeah.
Gotcha. Okay. Sunita is wondering, will the logs capture details such as what apps or elements in the app were touched or viewed?
It's tough to answer that question without knowing really what your app is. In general, though, things that I would consider at the application layer are not going to be covered by AWS, right? If you're talking about an app that's running on a virtual machine or in a container or something like that, AWS is not handling those logs. You need to make sure you send those to CloudWatch Logs, or send them to some AWS service or someplace. But that's actually one of the reasons. So you've heard me talk a lot about serverless today. That's one of the reasons that I like serverless, because when you use AWS services to be your app, right? Lambda, Dynamo, step functions, then all of their logs are your application logs, and those all tightly integrate into CloudWatch Logs, and now you've got all your logs in that one place. So it will capture all of those details. So that's again one of the benefits of serverless.
Okay, that's great. Thank you. Dennis is wondering, is there a better tool for managing CloudFormation drift? is there a tool that can take our current settings and apply them to the CloudFormation template?
So, okay. Importing existing resources into CloudFormation is possible. It's kind of a headache. But there is a tool out there called Former2, if you want to go check that out. Former2 was made by Ian McKay, and he has this tool where it will generate infrastructure as code from your existing resources. So you're going to give it permissions into your AWS account, and it will go and pull that using some automation. Now, as you can expect, it's not going to be the most beautiful code in the world, right? Like it works. And then what you'll want to do is kind of like refactor that a little bit, or, clean it up a little bit to make sure that it makes sense. And then you can use that as a starting point and kind of build from there. So that works. And you can kind of import the state into it. I do think it's a little bit of a headache, and that's one of the reasons I strongly recommend starting out new workloads, using an infrastructure as code approach, so you don't have to deal with that. But of course, so many people don't do that, and that's totally understandable. But yeah, Former2 would be the way to go, and that'll get you started.
Thank you. So Raj is wondering, what are the best practices around managing service quotas in an AWS account?
That is a good question. Service quotas can come up fast. You might not think that you're going to hit a limit, right, until you just really need to. And especially if you're deploying infrastructure through automation, and you apply your CloudFormation template and the template's valid, but you hit a service limit. So that is tough. But what my recommendation is just make it part of your regular routine to go and look at where you are near your quotas and go and request increases kind of before you think you need to. And that's one of the reasons that it can be good to get some AWS support and get contact with maybe an AWS partner that can help you work with that, or just have a service rep where you can tell them what you're planning on doing that might exceed those quotas, and they can get them raised before you need to. That would be my recommendation.
Awesome. Thank you. So William is wondering, does the IP manager handle IPv6 addresses also?
It does. It does, to the extent that AWS supports IP version 6. They've been increasing support there, but it's kind of incomplete. That's not to say that you can't use version 6 in AWS. You can, but in a lot of places, it's going to kind of terminate at some point, and then operate version 4 like within your private network. And I think in most cases that works out okay. But yeah, it does handle it.
Okay, we've got time for one quick question more. JB is wondering, could you speak a little bit about Bracket?
That's an interesting question, right? So Bracket's their quantum computing service. It's not something I have any significant experience with. So if you do, let's talk about it. I'd love to hear what you're doing with it. I understand that you can use it to build quantum algorithm stuff, using Jupyter notebooks, which is pretty awesome, and then kind of use their hardware to test different, quantum simulations, and that sounds super exciting. That's just not something that I do in AWS right now. But yeah, let me know if you do it more.
Right.
I'd love to hear about it.
All right, sir. That looks like all the questions we have time for this session. We're going to take a short break, but we'll be back at the top of the hour for our second session, Top Tips and Best Practices for Improving Your AWS Cloud Performance, led by scientist, author, and 20-time Microsoft MVP, Brian Posey. and moderated by our colleague David Rammel, the driving editorial force behind the must-read reporting in Virtualization and Cloud Review. Many thanks to Stephen Smiley for a great session, and thanks to our sponsors, SUSE and Certo, for making it possible. Now would be a great time to check out those extra resources on your console provided by our sponsors. We'll be back shortly for the third session. I'm sorry. I want to remind you that at the end of the third session, he tried to say, we will be giving away a DJI Mavic Air 2 drone to one lucky attendee, but you must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. And, of course, a special thanks to our sponsors, SUSE and Certo, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Top Tips and Best Practices for Improving Your AWS Cloud Performance. Our speaker for this session is Brian Posey, 20-time Microsoft MVP, freelance technology writer, and a commercial astronaut candidate. Throughout his career, Brian has written or contributed to dozens of IT books and created numerous full-length video training courses and published thousands of blog posts on a huge variety of IT and space-related topics. Many of those blog posts can be found in his Posey's Tips and Tricks column or in his new Posey's Moonshot column. Brian, it's great to have you here. Please take it away.
Hey, thank you so much, David. So, yeah, I'm Brian Posey, and, a lot of times I talk about Windows-type topics, but it's really great to get a chance to talk to AWS. I've been writing AWS content for Virtualization and Cloud Review since 2016, and I don't know that I've ever really gotten a chance to speak on the topic. So it's going to be a lot of fun for me, too. So let's go ahead and get started. So what I want to do today is I want to spend about the first half of the presentation talking about some potential causes of performance problems. And then once I get past that point, I want to talk about what can you do about it. Because anytime I do a session like this, it doesn't always work out, but I really like to try to give you something actionable that you can take back and put into practice in your own organization. So hopefully something that I'm going to be talking about today is going to be something that will be helpful to you. So with that said, let's go ahead and get started. Now, one of the first things that I have to talk about is that AWS, as I'm sure you all know, is an absolutely huge environment. I don't even know how many services there are. There are probably hundreds. Each one of those services has its own nuances, its own performance characteristics, and there's absolutely no way that I could do the justice to the topic of performance troubleshooting in AWS simply because AWS is so big and it's ever-changing. So that being the case, what I want to do is I want to focus primarily on EC2. If you're not familiar with EC2, EC2 is the virtualization platform. It allows you to run virtual machines in the cloud. So why EC2? Well, for one thing, that's where a lot of the performance problems that people have tend to happen. So that's one reason why I want to focus on that area. Another reason is because although there are some exceptions, a lot of the things that I'm going to be talking about with regard to EC2 environments and the way they perform also apply in at least some way to some of the other AWS services. So hopefully if you're having problems in some area other than EC2, then some of the things that I'm going to talk about will spark some ideas for dealing with those performance problems in other areas. So with that said, let's go ahead and get into it. Now, when it comes to troubleshooting problems with EC2, what I recommend is taking a multi-step approach. The basic idea is to look at the various areas where performance problems could potentially occur, and then work from the simpler things toward the more complex things. So, in other words, just take a really methodical approach to troubleshooting the problems. Look at something basic. If that checks out, move on to the next item on your list. See how that's working out. If there doesn't seem to be a problem there, move on to the next step, working from the more general to the more specific. So the trick is, as you do that, be sure that you look at all of the different areas that could be causing the problem until you eventually find the culprit. Now, before I move on, one thing that I do want to quickly mention is that one thing that trips people up sometimes is that there is absolutely no rule that says that you can only have one problem. I've been doing IT for over 30 years now, at the risk of making myself sound old. And during that time, one thing that I've consistently found is that the most difficult problems that I've ever had to troubleshoot, whether we're talking about AWS or Windows or something else, by far the most difficult problems I've ever had to troubleshoot, the reason it was so difficult was because there was more than one problem. Because what happens when you have more than one problem? Well, you do the things that should have solved that one problem, and maybe the characteristics of your overall problem change when you do that, but you still have an issue. And that can be really confusing because you've done what you think is right and yet an issue still exists. So if you run into a situation like that, don't rule out the idea that there may be more than one thing that's wrong. So the way that I like to think of troubleshooting AWS EC2 problems is in the same light as troubleshooting a Hyper-V problem, because there are a lot of parallels between them. And I just like Hyper-V because I've been using Microsoft forever. I'm a 21-time Microsoft MVP. But the same basic concept applies to other on-premises hypervisors as well, whether you're into VMware or KVM or something else. A lot of the troubleshooting techniques that you'll use in EC2 are very, very similar to those that you would use in an on-premises virtualization environment. But there are some exceptions. There are some things, of course, that are going to be unique to EC2, and we'll certainly be talking about those as we go along. So one of the things that makes it so tricky to troubleshoot problems with virtual machine instances, whether we're talking about Hyper-V or VMware or EC2 or whatever, is that there are a lot of different layers where a problem could potentially occur. And this all stems back to what I was saying just a few minutes ago about start with the general and work with the more specific, and try to validate the various layers and see if you can find a problem there. If you can't, then move on to the next one. So what are these layers? Well, I'm going to go into most of these in more detail in a few minutes, but let's just quickly run over the ones that are on the list on the slide. The first issue is resource contention. This tends to be more of an on-premises problem, but it can exist in AWS. I'll explain how in a few minutes. But the basic idea behind resource contention is that when you've got a host server, that host server has a certain number of physical resources associated with it. It's got a certain amount of memory. It's got so many CPU cores. It's got a certain number of disk IOPS that it can produce. And those numbers are baked into the hardware. They're fundamental to that system, and you really can't change it without doing any kind of doing a hardware upgrade. So resource contention happens when you've got multiple workloads that are competing for the same resources, and the system just doesn't have enough resources to deliver what is needed. So that's a resource contention. The next one on the list is a VM configuration issue, or Amazon likes to use the term instance. So if you have an instance that's poorly configured, that can cause a performance problem as well. The next thing on the list is a guest OS configuration issue, because it's entirely possible in an EC2 environment that you've got everything set up correctly, you've configured your instance properly, and you don't have any kind of performance problems on the Amazon end, but you do have something that's misconfigured inside of your virtual machine instance, and that's leading to your performance problem. So that's another layer that you need to check. The next one on the list is a host configuration problem. This tends to be a lot more relevant to on-premises environments, but the idea is that if you've configured your virtualization host improperly, then sometimes that improper configuration at the host level can cause performance problems. For example, Microsoft recommends that if you've got a Hyper-V server, and actually it's even more than a recommendation, it's a requirement from a licensing standpoint. But if you've got a Hyper-V server, then Hyper-V is the only service that you should run on that server. And if you start adding other services, even if you set all of the licensing issues aside and everything, those other services are going to deplete some of the resources that would otherwise be used for hosting virtual machines. So that's an example of a host configuration problem that can eventually lead to virtual machine performance problems. Then the next one on the list is a host hardware problem. Probably not something that you're going to run into in the Amazon cloud, because Amazon does seem to do, based on my own observations, a really good job of maintaining their hardware and keeping hardware problems at bay. But if you've got certain types of hardware problems on your host, then that can very well lead to performance problems. For example, in my own on-premises environment a few years ago, I had a disk controller that was going bad, and I didn't realize it. And what was happening is that write operations were having to retry several times before they would succeed as a result of that disk controller problem, and that was causing my virtual machines to run painfully slow. And of course, storage isn't the only type of hardware problem that can impact performance. Memory problems can do the same thing. More often, memory problems will cause corruption and it will cause your virtual machines to do weird things, but memory problems can also cause performance problems. And then the last one on the list, which is something that I'm really not going to be getting into in the context of this presentation because it's one of those things that you could really do an entire presentation on all by itself, is what I like to think of as multi-tier problems. So what is a multi-tier problem? Well, in a cloud environment, as I'm sure you know, a lot of workloads are distributed. You might have an EC2 instance that's running one of many components associated with that workload. So if that workload starts having performance problems, that issue may or may not be on that EC2 instance. It could be somewhere not even directly connected to that instance. It could be somewhere else on one of the other components that's associated with that application. You know, it's kind of funny. As somebody who writes about technology for a living, I tend to get a lot of press releases in my email. And one of the press releases I got just a couple of days ago, and I couldn't even tell you if this is true or not, but the press release claimed that most enterprise cloud applications have over 100 data sources that they use just for that one application. Truthfully, that seems a little bit much to me, but it doesn't seem entirely implausible either, so it could be true. Either way, if you think about a single workload being connected to over 100 data sources, any one of those 100 data sources could potentially contribute to a problem that you're having, as could all of the infrastructure components that are necessary in order to keep those data sources online. So all of the database engines, all of the virtual machine instances, any containers or microservices that you might be using, any one of those could be the source of a performance problem. So that's what I mean when I'm talking about multi-tier problems. So not something I'm really going to get into too much in this presentation just because it is such a big topic, but it is something that I wanted to at least mention so that you would be aware of. Now, when we start talking specifically about EC2, you really don't have to worry too much about host problems, as I said before, because Amazon maintains all of the hardware, and they tend to do a really good job of making sure that their hardware is healthy. Now, having said that, there is one potential type of host problem that you do need to be aware of. Amazon gives you the option of having dedicated hosts. So a dedicated host is essentially a physical machine that you lease, and you can run your own workloads on that machine. So Amazon puts controls in place whenever you do have a dedicated host, but there is a greater potential for you to have host-related problems if you are using a dedicated host, just because you have a bit more control over the host and there's a chance for potentially misconfiguring something. Whereas if you've got a host that you're sharing with other tenants, then Amazon puts all kinds of controls in place to keep the tenants' workloads separated from one another and to make sure that everything remains healthy. So let's talk about some of these list items in a little bit more detail. The first one that I talked about was resource contention. And I probably went into that one in an adequate amount of detail, but just as a quick refresher, the idea behind resource contention was that every host server has a finite amount of hardware resources. We're talking about CPU cores, memory, storage IOPS, all of that, and that has to be shared among all of the various workloads that are running on that host. Now, one of the problems that you can run into in virtualized environments is something that's casually referred to as the noisy neighbor syndrome. The idea behind the noisy neighbor syndrome is that somebody can set up a virtual machine, and that virtual machine can be way more resource intensive than it really should be. And it becomes so resource intensive that the performance of unrelated virtual machines that are on the same host begin to suffer just because that quote-unquote noisy virtual machine is depleting so many resources. Now, thankfully, this is something that you really don't have to worry too much about in an AWS environment just because Amazon does put those controls in place that help to prevent a host from consuming an instance from consuming excessive resources. But when resource contention does occur, performance problems are by far the most common symptom of that. And it's also not unthinkable to have resource contention issues in EC2, even if you're not using a dedicated host. So how in the world can that happen? Well, there are a couple of ways that come to mind. One possibility is that if you're using shared storage, then you can overwhelm the underlying storage. So how does that work? Well, imagine for a moment that you've got, 10 virtual machine instances in the EC2 environment. And I'm just picking a number out of thin air. And all of those 10 instances are connected to the same S3 storage, and they're all reading and writing data from that one bucket. Well, depending on what the underlying S3 architecture looks like and what kind of workloads are running on those EC2 instances, it's entirely possible that you could overwhelm that storage bucket, and that the storage bucket may not be able to keep up with the read-write demands that are being made on it by all of those virtual machine instances. So that's one form of resource contention, and certainly that would result in performance problems. Another possibility is that if you've got a virtual network connection between all of your EC2 instances and you're generating huge amounts of traffic between the instances, then maybe it might be possible to overwhelm that connection. Now, in all fairness, this isn't something I've ever seen happen in real life, but at least hypothetically it is possible. So the next item on the list was VM configuration issues. Now, this is also something that people tend to think of more as an issue that occurs in on-premises environments like Hyper-V or VMware, but it's very relevant to EC2. So why do VM configuration issues occur? Well, if you think about it, every application that you've ever installed has a certain amount of hardware requirements associated with it. Typically, when you get the application, it will tell you it needs X number of CPU cores, running at a certain speed, and so much memory. And then it might even say, these are the minimum requirements, but here's what we recommend. Well, those requirements don't go away just because you're running the virtual machine, or excuse me, the application up in the cloud within an EC2 instance. Those hardware requirements still apply, and they apply regardless of where the application is running. So if you undersize the virtual machine instance, then you're going to naturally experience performance problems because the application isn't getting what it needs. Another mistake that people tend to make sometimes is that when they're sizing a virtual machine instance to run a particular application, they tend to think about the here and now as opposed to what the demands are going to be on that application in the future. And this is something that I've seen countless times in the real world. The idea is that an organization deploys an application, and maybe it's got a minimum set of hardware requirements and a recommended set of hardware requirements. And so the organization gives that application enough resources to satisfy the recommended hardware requirements. And at first, everything works great. But then over time, that application becomes slower and slower. And there are any number of potential reasons why that can happen. But the big reason is that when the application is first deployed, you might have minimum demands being made of that application because it's brand new, nobody's quite used to using it yet. It certainly hasn't become mission critical at that point because there's not really much data associated with it. But as more and more users begin using that application, and as that application begins to gain additional traction within the organization, more and more demands are going to be made of the infrastructure that's hosting that application. So if that EC2 instance was minimally sized to be able to handle the application, it may not be able to keep up with the demand as the workload for that application increases. And that's certainly something that I'm going to be talking a lot more about in the second half of this presentation. So what do I mean when I talk about virtual machine instance sizing? Well, I wanted to throw the screen capture up here just for the benefit of anybody who might not have worked with EC2 in the past. When you set up an EC2 instance, it's kind of like setting up a virtual machine on premises. Whereas when you set up a Hyper-V virtual machine, you're prompted as to how much memory you want to assign to the virtual machine, and then once the virtual machine has been created, you can go in and give it additional CPU cores and create additional storage. Well, EC2 does the same basic thing, but Amazon uses predefined sizes. So when you create a virtual machine instance in the EC2 cloud, you're prompted to choose what size you want that virtual machine to be. And these virtual machine sizes range from what they call micro virtual machines all the way up to extra large, and there might even be some sizes beyond that. I'm not really sure. But the size reflects the number of virtual CPUs that the virtual machine instance will have, the amount of memory, and it also affects the price. So what tends to happen a lot of times in the real world is that an organization will need to deploy a new workload. They'll get to the screen right here where they pick a virtual machine size, and they'll see the pricing and be like, whoa, that's going to cost us a fortune to run this. Let's use a slightly smaller virtual machine size, and I'm sure it'll be okay. And that very often leads to performance problems. Fortunately, there is a workaround for this. It's entirely possible to start out with an undersized virtual machine and then change the virtual machine size as you go along. Now, doing that can be disruptive, but it is something that you can do, and I'll show you how to do that later on in this presentation. It's at one time it was a really convoluted process, but it's way easier than it used to be. It's something that you can do with a few mouse clicks. Now, I talked earlier about the potential for guest operating system problems, and that is something that you have to consider if you're having problems with a workload running in an EC2 instance. The problem might not be related to EC2 itself or even to the instance. It could be caused by something that's running inside of the instance at the application level or at the guest operating system level. And realistically, that something that's causing the performance problems could be anything. So I wish I could give you a checklist and say, check this, check this, check this, but it's going to vary heavily depending on what operating system you're running and what applications you're running. But just to give you a really quick example, consider the Windows indexing service. The Windows indexing service tends to make a lot of demands on the hardware, particularly the disk. If you've got a lot of data, it will go out and try to index that data. So if you've got a minimally sized virtual machine and it's just barely got enough hardware resources to run Windows and maybe a small application, and then you go and enable full text indexing, well, that may end up pushing the virtual machine beyond what it's really capable of, and you're going to see some significant performance problems as a result of doing that. So the idea being that there are things that you can do within a guest operating system that may cause performance problems. Now, another thing to consider is that drivers can potentially come into play. Now, this is much less of an issue today than it used to be, but just as physical machines require drivers for the operating system, virtual machines require drivers as well. Now, if you're installing one of the AMIs that's provided by Amazon, you really don't have to worry about this because the drivers are baked right into the AMIs. But if you're building a custom AMI or whatever you want to call it, then that does potentially become a concern. So I've talked quite a bit about some of the different things that can contribute to performance problems. So now I'd like to kind of shift the discussion a little bit and talk about what can you do about it. Let's say you've got an EC2 instance that is behaving badly. What can you do in your own environment to resolve those performance problems? Well, unfortunately, every problem is different, but I do want to give you a few hands-on type things that you can do to address some of the more common performance problems that you're likely to encounter in EC2 environments. So one of the big ones, and in all honesty, this is the very first thing that I would recommend checking, is to make sure that the instance is receiving sufficient hardware resources. And this goes back to what I was talking about just a few minutes ago with virtual machine sizing. If a virtual machine is undersized, then it's probably not going to perform very well. So, as I mentioned a moment ago, there is a way that you can go in and change the virtual machine size and make it bigger. Now, that's great. But at the same time, you have to consider the fact that changing the virtual machine size is, at a minimum, it's going to be disruptive because you have to shut down the virtual machine instance in order to change its size. So you could have a workload that gets disrupted as a result of having to do that. So changing the size isn't something that you want to do just on a whim. Also, you have to consider the cost because the bigger the size, the more it's typically going to cost to run that virtual machine instance. So there's going to be a cost increase associated with increasing the virtual machine size. Now, depending on how much bigger you make the instance, that cost increase may or may not be significant, but it's definitely something that you need to think about. The point is that anytime that you change the instance type, that operation is going to be disruptive. It could potentially be expensive, and it might not necessarily fix your problem. Now, I know that sounds weird to hear, but it's true. Because if the problem stems from something other than instance size, then making the instance bigger isn't going to fix anything. So with that in mind, it's really important to do a little bit of digging and find out if your problem is truly related to underperforming hardware before you go and mess with the instance size. So how do you do that? Well, there are a couple of different options. I'll show you two options. The way that I like to do it is from inside of the virtual machine instance itself. And that's just because of personal preference. I tend to run a lot of Windows virtual machine instances, and I'm a Microsoft MVP, so I like messing with Windows, and I like doing things in kind of the Windows way, so to speak. And Windows contains a built-in tool called the Performance Monitor, and you can use the Performance Monitor to find out if a virtual machine instance is starved of resources. So you can see a screen capture of what the Performance Monitor looks like on the screen. You can access it by typing perfmon at the Windows Run prompt, and it will take you to the screen right here. Now, I don't want to get too far off the rails talking about Performance Monitor, but the basic idea behind it is that Microsoft gives you a really large collection of what it calls counters. And each one of these counters is designed to measure a particular performance metric. If you look at the screen, you see a big blue arrow pointing to a line just beneath the graph. And that line is a counter. This particular counter is percentage processor time. And it shows you the percentage of time that the CPU resources are in use. So on this particular virtual machine instance, the CPU is being used to less than 10% of its total capacity. It's totally normal to have spikes that go much higher, but on average, less than 10% of the CPU resources are being used. So consider what I just said a moment ago with relation to the screen capture. Suppose this particular virtual machine instance was having performance problems, and you thought that maybe it's not getting enough CPU time, I'll just make the virtual machine instance bigger. Well, making the virtual machine instance bigger in this case wouldn't do anything because this virtual machine has plenty of CPU resources available to it just based on the screen capture. So the performance problem obviously lies elsewhere. Now, what if you're not using a Windows virtual machine instance? Suppose you're using Linux or Apple or something else, or you just don't like using Performance Monitor. Well, there is another option, and that's to use a native Amazon tool. So right here, I'm in the EC2 dashboard, and you can see one of my virtual machine instances. So what you would do is you would click on this instance, and then when you do, that's going to take you to the instance summary screen, which you can see right here. And you'll notice that there's a great big blue arrow pointing to a monitoring tab. If you click on that tab, it's going to take you to this screen right here. And you're presented with a number of different graphs that show you how that virtual machine instance is actually performing. So you can see things like CPU utilization. You can see the network traffic in bytes and in packet count. You can get a feeling for your disk reads and writes and how heavily your CPU is being used as well. So you have all of this information that's being made available to you. And if you need additional monitoring data, you can get that as well. If you look at the upper right corner of the screen, you'll see another blue arrow, and it's pointing at a button labeled Manage Detailed Monitoring. If you click on this button, it's going to take you to this screen right here. And you can select Enable, and that's going to refresh all of your monitoring graphs so that they get updated every minute. So you're going to get a lot more detail in your monitoring data. But it is worth noting that there is an additional charge for enabling this detailed monitoring. So depending on what type of performance problem you're having and how heavily you're depending on this monitoring data to resolve that problem, enabling detailed monitoring for the instance may or may not be worth it. So let's say that you do find that the system is being deprived of hardware resources. It's not getting enough CPU resources, or it doesn't have enough memory associated with it, or something like that. What do you do about it? Well, as I've alluded to several times throughout this presentation, one of the best things that you can do in a situation like that is just change the instance type. You can very easily make an instance bigger. And at the very beginning of the presentation, I mentioned that I tend to do a lot of writing for Virtualization and Cloud Review. There's a link on this slide to an article that I wrote on this very topic. So if you need more information than what I'm able to present today, I would encourage you to visit this link, and that will take you to a place where you can read in detail how to perform this procedure. But it's not very complicated. So what do you do? Well, before you go and change the instance size, there are a few things that you need to keep in mind. First, as I mentioned, the process is a lot easier than it used to be a few years back, but it may still require some planning. This is particularly true because you're going to have to take that instance offline in order to change its size. So you may have to plan for that outage. You just don't want to shut a virtual machine instance down in the middle of the workday while everybody's using that workload. Another thing to keep in mind is that not every instance type is compatible with every instance. So you've got to make sure that you're changing to a compatible instance type. Just for example, not all instance types support EBS optimization. EBS is the elastic block storage. It's the storage that most virtual machine instances use. So you may find that a particular instance isn't compatible with certain instance types. So you're going to want to make sure that you choose an instance type that is going to work with the virtual machine and the way that it's configured. And incidentally, you're not just limited to increasing the virtual machine instance size. You can decrease it as well using the exact same technique that I'm about to show you. Another thing to consider is that you should create a backup before you do this, just in case, because there's always the potential that something could go wrong. I've done this several times in the real world, and it does seem to be a safe procedure. But anytime that you go messing with something like changing the configuration of a virtual machine instance, there's always the potential for some unforeseen disaster to occur. So I strongly recommend just creating a backup first, just in case. And then one more thing that you need to be aware of is that you're going to have to disable hibernation before you can change the instance type. Because if you don't disable hibernation, then the change instance type option is going to be grayed out. So if you go in and you change the instance type and you find that the option is grayed out and inaccessible to you, just check and see if hibernation is enabled. So how do you actually change the instance type? Well, it's really easy to do. Right here, I'm on the EC2 dashboard. But what I've done is I clicked on the Actions menu, and then I went down to Instance Settings. And then when I clicked on Instance Settings, that popped out a submenu. And then there's an option on that submenu, Change Instance Type. So just choose that. When you do, that's going to take you to this screen right here. And you can see the current instance type. In this case, this particular instance is a T2 micro instance. And then you can select a new instance type. For example, I've got T2.small selected. So you would make your choice, and then once you've chosen the instance type that you want to use, click Apply, and then that's all there is to it. Now, one thing that I do want to point out is as you look at the screen, you'll notice that there's no description of what a T2.small instance is. So you may have to go through the process of creating a new virtual machine instance, not create it to completion, but just go through the process just to get access to that list of virtual machine instance types to figure out what type you really want to use. And then you can always cancel out of it and then go back to the screen. So once you've clicked Apply, you'll see a message like this telling you that the instance type was successfully changed. And you'll notice that the instance state is still stopped, so you will have to start the virtual machine instance manually once the process completes. Now, another thing that you can do if you're having performance problems with an instance is to try moving the instance to another region. Because let's say that you've got an on-premises environment, and then that on-premises environment connects to a virtual machine instance up in the Amazon cloud. And for whatever reason, that instance exists in a region that's on the other side of the world, wherever that may be. Well, even if everything is optimally configured with that instance, you're still going to have a bit of latency because every packet that you send to or receive from that instance has to go all the way around or all the way to the other side of the world before it can even be processed. So you're going to incur a couple seconds of latency every time that you send a packet to that instance. Now, a couple seconds might not seem like a big deal, and in many cases it's not a big deal. But if you're trying to do something that needs to be done in near real time, or if you're sending a flood of random packets to an instance, having that instance located really far away from you could potentially be problematic just because of that latency that occurs with each and every packet that's being sent. So you may be able to improve performance by moving that instance geographically closer to where you are. Now, before you do that, it's important to think about anything else that might need that instance. There could be a very good reason why that instance is in the location that it's in. It could be done for regulatory reasons. Maybe there's some kind of law that this instance has to reside in a certain region. That's fairly common. But it's also possible that that instance interacts with other services that also happen to be located in that region, and you may end up doing more harm than good by moving that instance into a region that's closer to where you are. So those are all things that you have to think about. So how do you move an instance to another region? Well, there's no easy way to do it, but there are a few different options. The best option that I found is to create a snapshot of the instance and then copy that snapshot to the other region and then use that snapshot to create a virtual machine instance in that destination region. And I've provided a link at the bottom of the slide to an article that I wrote on how to do exactly that. So let's take a high-level look at what that process looks like. What you can do is select a virtual machine instance, and I'm in the EC2 dashboard on the screen, by the way. So create a snapshot. If you click on the Actions menu, you have an option to copy a snapshot. So once that snapshot's been created, you copy it. Then you're taken to the Copy Snapshot screen. You'll generally want to provide a description on the screen capture. I didn't for whatever reason, but typically you'll want to provide a description just to help keep track of what the snapshot is. And then you choose your destination region, and then there's also a checkbox that you can optionally select if you want to encrypt the snapshot. And then just click the Copy Snapshot button, and that will copy your snapshot to the destination region. Then, once you're in that region, what you can do is go back into the EC2 console, go to the Actions menu, and then there's an option, Create Volume from Snapshot. So you can create a volume based on the snapshot that you just copied from the other region. And then you can use that volume as the basis for a brand new virtual machine instance. Now, one more thing that you can do, and this is one of those things that gets a little bit technical, but it's not overly so, is to change the storage volume type. And this is kind of the big one. If you haven't been able to fix performance problems in any other way, a lot of times this will fix the performance problem when other methods won't. So one of the things that you have to understand is that when you create a new EC2 instance, one of the steps in the process of creating that instance is to specify what type of storage you want to associate with that instance. So let me kind of skip ahead for a second, and I'll show you exactly what that looks like. Okay, so what you see right here on the slide is an excerpt from a screen that is displayed while you're creating an EC2 instance. And you can see that you're prompted to configure the storage where the root volume will reside. And there's also an Add New Volume button that you can use to create additional storage. We're not going to worry about that for right now. Let's just focus on the root volume. So as you can see, there are two pieces of information that you have to provide when you're creating that root volume. The first one is the size. That's where you see the 1x30, that's 30 gigabytes. So if you were to just accept the defaults, you're going to create 30 gigabytes of storage that are going to be used for the root volume. The other option that you see is the storage type. Right now this is set to GP2. GP is general purpose. So you're going to place that virtual machine on 30 gigabytes of general purpose storage. And in a lot of cases, that works great. I mean, that's the default behavior, and I'm sure Amazon made that the default for a reason. But as we all know from our time in IT, the default isn't always optimal. It doesn't work in every situation. So even though GP2 storage or general purpose 2 is the default, it's not always going to necessarily be the best option. So what can you do to improve your experience with storage? Well, Amazon actually gives you quite a few different storage types to choose from. I believe off the top of my head, I think there are 7 of them. I'd have to check that count. But there are several that you can choose from. And there are exceptions, but by and large, when you select a storage type, that storage type can be either optimized for IOPS or it can be optimized for throughput. Now, on the surface, they'll sound like the exact same thing because IOPS refer to how fast your storage is going to be, but throughput also refers to how fast your storage is going to be. But there's a very key difference between the two, and this is something that's super important to understand when it comes to resolving virtual machine storage problems. When you're talking about optimizing for IOPS, what you're really talking about is random IOPS. So for example, let's suppose that you've got some storage and it contains a database. And you've got an application that's just hammering this database and it's constantly reading and writing records. Well, those are going to be random IOPS. IOPS are going to be generated separately for each operation that you're performing. Typically, they're going to be really small, but there's going to be a lot of them. So IOPS optimized storage would be ideal for something like that because you're going to have a large number of IOPS, and each one of those IOPS is going to be relatively small. Now, throughput, on the other hand, is also a metric that sort of kind of is an indication of how fast the storage is going to be. But when you have a throughput optimized volume, it's a lot more suitable for large linear read-write operations. Now, when I say linear, I'm not talking about linear like in the context of a tape, but what I am talking about is doing things like reading or writing large files. So things where you're not just having a gazillion bursts of tiny little data, but rather big chunks of data that are being read or written to. For that, you would generally be better off using throughput optimization. So it's really important to understand the difference between IOPS optimization and throughput optimization. Now, when you're picking between the two, IOPS optimization is simple. You just tell EC2 how many IOPS you need, and it does the rest. No muss, no fuss, simple as that. When it comes to throughput optimization, though, there's a whole system of burst credits, which I'll talk about in just a second. But it works entirely different from the way that IOPS optimization works. So, if I can find my mouse here, it's being stubborn. There we go. Okay, so when you're configuring your storage, as I mentioned, you can choose storage types, and these are the storage types that are available. I'm not going to go through all of these in the interest of time, but just be aware that there are a number of storage types available. And some of these are optimized for IOPS, and some are optimized for throughput. You'll notice that IO1 and IO2 are provisioned IOPS. Those are IOPS optimized storage types. Then we've got one, the second to the last one on the list, throughput optimized HDD. That's obviously a throughput optimized storage type. Now the GP2 that is used by default, even though it's not listed as such, that is a type of throughput optimized storage. So let's take a look at how this works. Now, I mentioned a moment ago that when you create IOPS optimized storage, you simply tell EC2 how many IOPS it is that you need. And if you look at the big blue arrow, it points to a box where you just type in the number of IOPS that you want. Now, one thing to keep in mind is that there's a relationship between the number of IOPS that you can achieve, the capacity that's going to be available on the volume, and your overall cost. So all three of those factors are going to be tied together. The reason for that is really simple. Let's say that you need some ridiculously huge number of IOPS. I'll let you figure out what that number is. But let's say you need a huge number of IOPS. Well, there's probably not going to be any type of disk that can single-handedly deliver that number of IOPS. So the way that Amazon achieves that IOPS capacity is by striping the read and write operations across multiple disks simultaneously. So as the number of disks increase in order to handle that requested IOP workload, the capacity also increases because you're adding disks. And because that capacity increases, your costs are also going to increase. So if you want a really low capacity disk, you're going to be sacrificing some IOPS in the process. So you do have that relationship between IOPS, capacity, and costs. So with that said, let's take a look at throughput optimized. Now, throughput optimized, you don't really have to do anything to configure it, but there is a system of burst credits that you do need to be aware of. Burst credits are essentially credits that are available to you. It's not something that you have to go buy or anything like that. It's something that Amazon gives you automatically. And what these credits are is they're just a metric that allows you to handle spikes in throughput. And so you accumulate these slowly over time. It happens automatically. There's nothing that you have to do to accumulate these credits. And then whenever there's a spike in activity that goes above the baseline throughput, then Amazon will tell the disk to go ahead and handle that spike, but it will decrease your throughput credits a little bit in the process. So why is this important? Well, think about what happens a lot of times with EC2 instances. You may find that an instance, when you set it up, it works really, really well first. Everything performs just the way that it should, and then it will gradually start to slow down. Well, in some cases, certainly not every case, but in some cases, the reason why that's happening is because you've exhausted the throughput credits. So what happens is that the amount of traffic that's being directed at the disk exceeds the baseline throughput that disk is rated for. So when that happens, you're using that throughput credit to absorb what Amazon sees as activity spikes. And then once those credits are exhausted, then the maximum that it will deliver is the baseline throughput. So everything slows way down because the disk is no longer able to keep up with the workload. So that's just a really quick summary of how throughput optimized volumes work. And then, of course, one last option that I'll want to throw out there is if you're unable to resolve the EC2 performance problems and you're at your wit's end, see if Amazon offers a managed service that you can use in place of a virtual machine instance. A lot of times you may find that a managed service will perform better than an EC2 instance, depending on what it is that you're trying to do. So with that said, I know I am about out of time. I'd like to go ahead and open it up for questions.
Okay, and we do have some questions, and I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. And let's just take them on a first-come, first-served basis. Brian, if you want to follow along in the console, here's a question from JB. Instead of using EC2, why not use Elastic Beanstalk? He put this question in right after you started your presentation.
Elastic Beanstalk can certainly be an option for AWS-based workloads. It's kind of one of those things where I just don't have time to talk about everything, so I decided to go with EC2.
Okay. Here's a question from Raj. Any recommendations on performance tuning for ECS, NGINX servers? We use auto-scaling. However, it only relies on CPU and memory triggers.
Yeah, I'm really not familiar enough with NGINX to really be able to give you any good advice on that one. Auto-scaling does seem like the most obvious choice, but I honestly don't know if there's other options beyond that or not.
Okay, I'd like to remind the audience we have several more minutes for questions, so please send them on in and take advantage of this opportunity for some one-on-one with an expert. Next question comes from JB again, his second question. Does having AWS Outposts provide EC2 benefits for the organization's critical apps?
Yeah, it could potentially, because you're reducing latency latency by having that a lot closer to your on-premises environment rather than being up in the cloud. Presumably with something like Outpost, you've probably got a higher degree of control over the configuration as well. Outpost isn't something that I've really got any direct hands-on experience with, so I can't really say for sure how much of a performance benefit that you would get, but I would have to assume that you would gain some kind of benefit just in what you would make up for in latency alone.
Okay, great. The next question in the console reads, are the native EC2 templates optimized for performance, or should I be building custom templates?
That's a really good question. The native EC2 templates, they are optimized in a way. But you have to remember when you're using those templates that Amazon doesn't know what your workload is. So it's optimized for performance, but it's not optimized for a specific workload, if that makes sense. So if you're running a workload that's going to benefit from additional optimization, you may be a lot better off building your own template than using one of the default ones. But for a lot of things, using the built-in AWS templates is going to be just fine.
Okay, moving right along. The next question reads, do regions even matter since high-speed connectivity exists between AWS regions?
Yeah, absolutely. They matter because, it's easy to think about the whole region thing is electricity flows at the speed of light and, 186,000 miles per second. So there's really no difference in communicating with something that's across the room versus the other side of the world. But you have to remember, you don't have a direct route from point A to point B. There are going to be a number of different routers that a packet has to pass through en route to that destination, and it's also going to be competing with other traffic. So generally, if you can put something closer to you, that's only going to be a good thing because you can minimize the latency associated with the packet having to go through all those routers. The packet's probably going to have to compete with less traffic just because you're passing over fewer hops. So yeah, you may see a very real performance benefit by having that put closer to you.
Okay, the next question reads, is it best to just skip EC2 and use managed services instead?
I think that ultimately comes down to what your workload is and what your individual needs are. Certainly, you could make a case for using managed services in a lot of situations. The real advantage that something like EC2 gives you is control, because when you're using a managed service, you have to do everything Amazon's way. They provide a managed service that does one thing and it does it well. If you've got any kind of customization that you need to make, you're probably not going to want to use a managed service. Another thing that you have to think about is cost. Sometimes it may be more cost-effective to run a particular workload in a virtual machine versus in a managed service, but the opposite can also be true. And then also, managed services have certain performance characteristics associated with them. So depending on your workload, it may be a bit much for a particular managed service, or it might fit right in. But those are all things that you need to look at when you're making that decision, rather than just saying a managed service is always best or an EC2 instance is always going to be best.
Okay, great answer. Well, looks like that's all the questions we have. So thanks again, Brian, for an excellent presentation and answering all those questions.
Thank you for having me.